Hi, and welcome to today's lesson on 4.8 triangles and coordinate proof. Before, we've used coordinate geometry to prove triangle congruence. Now we want to position and label triangles for use in coordinate proofs, basically taking advantage of the coordinate plane and helping us figure out properties of triangles mathematically. So the first problem here asks us to position and label this right triangle XYZ with one of the legs, which is side XZ, and some number D units along the coordinate plane. So we don't know the number of how long XZ is, but we know it's D units long. So on the coordinate plane, we're going to go ahead and put X here at 0, 0, and then Z we know is D units long. So we want to put one side at least on the axis of this coordinate plane. The x-axis is convenient here. So we're just going to put point X at 0, 0, and we'll call point Z some distance D away from 0 on the x-axis. So it would have coordinates D, and it's still on the x-axis, so it has y coordinate of 0. So since triangle XYZ is a right triangle, the x coordinate of y up here is also going to be 0 because they should lie on this axis because these two sides are perpendicular. So over here we have we don't know the value, the height of this triangle, so we're just going to call that B because that's where it crosses the y-axis most likely. But the important thing here is that we do know the x-coordinate, which is 0, just like this x-coordinate. So that's what our triangle, the best way we can set that up on a coordinate plane. Maybe not the best way, but the most appropriate way to help us solve certain attributes. So go ahead and check your progress here. We're going to look at some pictures on the following slide, which would be the best way to position and label equilateral triangle ABC. Notice that side BC is W units long on the coordinate plane. So we need an equilateral triangle, and side BC is going to be W units long. So go ahead and take a look at these four triangles and figure out which one that would match. And hopefully you chose D here because it is in fact an equilateral triangle, and BC has to be the side that is W units long, so it would have this W x coordinate. So just the step-by-step process here that we're using. Always use the origin as a vertex or the center of a triangle, and then place at least one side of the triangle on an axis. We want to try to keep the triangle within the first quadrant, so we're dealing with positive values. And we also want to use coordinates that make computations as simple as possible. So in this example, they're asking us to find the missing coordinates of the isosceles right triangle QRS. So Q is on the origin, so we obviously know its coordinates are going to be 0, 0. And then the x coordinate for S is going to be the same as the x coordinate for R because it's a right triangle. If this is on the axis, then this has to be going, this side SR has to be going straight up. So both S and R are going to have some x coordinate we'll call C. It doesn't matter what you call it, we just chose C arbitrarily. The y coordinate for S is the distance from R to S, and we know it's isosceles. If it's an isosceles right triangle, these two sides have to be the ones that are equal because the angles opposite of them have to be equal, and only one angle can be 90. So we know that QR and RS are congruent. The distance from Q to R is going to be C, and the distance from R to S has to be the same because those two sides are congruent. So we can call the x coordinate for SC, and we can call the y coordinate for SC as well. So we know Q is at 0, 0, and S is at C, comma C, or whatever variable you choose, as long as both coordinates are identical. So go ahead and see if you can take a look at this isosceles right triangle ABC and figure out the missing coordinates of A and C. And you should have gotten answer C. You obviously have C at the origin 0, 0, and you have A with the x coordinate 0, and because it's isosceles, AC and BC are congruent, so the distance from B to C has to be the same as the distance up from C to A. So we have x is 0 and y is that distance D. So now we want to take a look at a proof to show that the segment that joins the vertex angle of an isosceles triangle to the midpoint of the base is perpendicular to the base. So in other words, this segment YW that joins the vertex to the midpoint of the base, which is what we're going to call this point W. So first we want to position it on the coordinate axis like they did here, with one vertex at 0, 0. Then we want a line segment along the axis. They chose to use the x-axis and put xz on it. And they chose to label the point y AB, and you'll see y here. Obviously x is at the origin, and z has a y coordinate of 0 because it's on the x-axis. Its x coordinate is 2a, because if we call this point y a, and that's the midpoint between x and z, then z's x coordinate is going to be double that. So what we're given is that triangle XYZ is an isosceles triangle, and that XW is congruent to WZ because W is the midpoint of those. And we want to show that YW is perpendicular to XZ. A triangle over here. By the midpoint formula, the coordinates of W are going to be halfway between X and Z. So that midpoint formula, if you remember, is you take your two X values and divide by 2. My two X values would be 0 and 2A over 2. That simplifies. I have 2A over 2, which just becomes A. My y coordinates are both 0, so the midpoint of 0 would be, I'm sorry, my y coordinates would be 0 plus 0 over 2, which becomes 0. So this point we can know for sure is A, comma 0. The slope of YW is the change in y, which goes from 0 to B. So we'll say 0 minus B. And the change in x is nothing because it stays at A between these 2 points. So we have 0 minus B over A minus A. A minus A becomes 0, which is undefined. The slope of xz, on the other hand, would be a change in y, which is 0, over change in x, which is 2a. So it still becomes 0. Because one is undefined and one is 0, we know that they're perpendicular. Remember that the general rule for this is kind of a different case because you have this undefined here. But the general rule for slopes to be perpendicular is they multiply together to give you -1. So in other words, they're the negative reciprocal of one another. So go ahead and take a look at this triangle. We're going to give you a coordinate proof on the next page to prove that the segment drawn from the right angle to the midpoint of the hypotenuse is an isosceles right triangle is perpendicular to the hypotenuse. So in other words, prove that this segment is perpendicular to this segment here. So here's your proof. We say the coordinates of midpoint D are 0 plus 2a over 2, 2a plus 0 over 2, which is going to simplify to AA. The slope of segment CD is 1. The slope of segment AB becomes -1. CD and AB are perpendicular because why? Is it because their slopes are opposite? You have a positive and negative. Is it because the sum becomes 0? Is it because the product is -1? Or is it because the difference is 2? Hopefully, as I mentioned earlier, you chose C, that the product of the slopes is -1. So now we're going to look at this last proof here. Write a coordinate proof to prove that the outside of this drafter's tool is shaped like a right triangle. The length of one side is 10 inches. The length of another side is 5.75 inches. So they chose to place it on the coordinate with a vertex at the origin. So we're going to call this distance 10 and this distance 5.75 because those are the two sides of the triangle. The slope of ED is going to be 10 minus 0, your change in, I'm sorry, this is ED here. 10 minus 0, which is your change in y, over your change in x, which is 0 minus 0. That slope is undefined, clearly. Then when we look at the slope of DF, you have 0 minus 0 over 0 minus 5.75. So this DF slope is 0. Therefore, since these two are perpendicular, it is indeed a right triangle. So go ahead and check out your progress here. Tracy wants to write a coordinate proof to prove that this flag is shaped like an isosceles triangle. The altitude, or the height of this triangle, is 16 inches. So this distance from the vertex to the base is 16. And the base, this segment AB, is 10 inches. So thinking about that, what we want to find is what coordinate this point C would be. So think about that. That's going to be the multiple choice on the next page. So should we use for C? And hopefully you chose the point 16.5, because if we go back and look at the triangle, altitude would have given an x coordinate of 16, and the height, C becomes is the midpoint between A and B in an isosceles triangle. So the height is going to be half of this base 10, which is actually 5. So that's why we choose D. And that's going to conclude today's lesson. Hopefully you get a sense of where we want to place triangles on the coordinate plane and how we can use our own points essentially to come up with proofs. And we're going to use this later on in the next chapter. Thanks for watching.